Hello, everyone. Today, I would like to introduce a topic about the discovery of new deep-sea hydrothermal vent communities in Southern Ocean and implication for biogeography. First, I would like to introduce where the research takes place. It takes place in East Scotia Ridge, also called ESR in Southern Ocean. It is a backyard basin in geology, and it is 500 kilometers then proceeding at an average of 70 millimeters per year to spreading. And we do research at E2 and E9, these two ridge. And I would like to think about why this ridge is very important, because it is isolated from other ocean. Although it is near Atlantic Ocean, but the species there are very distinct from there. It represents a new biogeographic province, and many new unique species like yeti crabs in this research are found. I will talk it later. It has very high biomass, despite it is in a very cold environment in Southern Ocean. And it helps us to understand the deep sea ecosystems. Firstly, I will briefly take a look at what is hydrothermal vent. We firstly discovered it in Galapagos Ridge in 1977. It can be found in the rift or mid-ocean rifts, and its feature is black smoker chimneys. It would release many sulfides like hydrogen sulfides that can make some primary production to do chemosynthesis. And what is chemosynthesis? It is a kind of creatures to generate energy without light, just like photosynthesis. Some microorganisms live in hydrothermal vents would absorb some carbon dioxide and hydrogen sulfide to generate some nutrient and energy. And that is the main support of the deep sea environment food web. Then, what is the biogeographic province defined? It is defined by the species overlap across regions. Compare the species presence or absent in the ocean. For example, some species are similar in Southwest Pacific and Indian Ocean. They all find the similar species. So some scientists classify these two areas as a same biogeographic province. And other biogeographic province as shows follows. Then this is the distribution of hydrothermal vent fields around the globe. In this research, we focus on East Scotia Ridge on here. It is mainly backyard spreading center. And how do this research conduct? We use ROV, also called remotely operated vehicle, to see the deep sea environment by photographing and other investigation. Also, we use TOVI and CTD sensor, or this string instrument, and we use some biological method to sampling and do microbial analysis by this 16S rDNA. Okay, and let's compare with E2 and E9, these two hydrothermal settings. E2 is a little bit deeper than E9, and it is terrace. E2 is terrace stair-like structures, while E9 have many lavas disrupted by fissures. It is more complex than E2. E2 have more stable black smokers and diffuse flow. Diffuse flow is a cooler water than black smoker, and E9 have a black smoker and diffuse flow decrease southward to the crater. So we can see the north of the E9 have the highest temperature of vent fields, while south of E9 have lower one. And this two figure shows that the highest temperature and pH of these fields. We can find that the pH of E2 and E9 are both acidic. And other ions or properties in the ocean are shared below, and we can find E2 have the similar properties as the seawater of sodium and chloride, while E9 have lower sodium and chloride. That means that some chemical activities occurs more frequently in E9, and also silicate are higher in south of E9. Okay, and let's take a look at microbial composition. The proteobacteria dominates these two rifts, accounting for 70% and 66% respectively, and it can be found in other oceans. The main character in this East Scotia Ridge is Yushih crabs. It is very abundant in these areas, up to 600 individuals per square meters in E9. It have hair-like structures called setae, can leave some bacteria on it, and it would eat on these bacteria. And we can find that male crabs are closer to vents, while females and juveniles are found in outer areas. This is the image of Yushih crabs in E9 hydrothermal vents. It is very high density in these areas. And other creatures like stud barnacles, sea spiders, and vent snails, it is also very high density. And limpets and sea anemones on the diffuse flow zone, because it cannot afford too high temperature. And also we can find some worms, sea stars, and octopus. Okay, let's discuss what makes Southern Ocean unique. In this research, we do a multivariable regression tree, also called MRT, shows that Southern Ocean is a new biogeographic province. It means that there is very different species in these areas, and animals live there are hard to move to other place. Also, we call it has low dispersal activities, and in these areas we cannot find some typical vent fauna in other hydrothermal vents, like tube worms, mussels, and shrimps. They all don't is it in East Sasha Ridge. And the cause is the polar form to make it hard to go to other place. It has a strong isolation. And their environment are very extreme. Also, they have a Antarctic circumpolar current called ACC that can strict the species in there, but also can make the connection with other ocean. So it can be not only a gateway but also a barrier to world ocean. Okay, let's go to the conclusion. We can see that the Southern Ocean landfill is a unique ecosystem, and it is a genuinely separate biogeographic province. It also shows the connection between different ocean regions. So it is very important for further exploration of higher latitude. Thank you for everybody.
How are these vent animals different from those in the Pacific Ocean?
Because this research say that it is somehow similar to other ocean, but if in Southern Ocean it finds some non-defined species, then because this research is in 2012, it is very previous research, and in that time they found some previously non-defined species like yellow crab.
Thank you.
In page 19. What causes the animals have low dispersal potential?
Because their environment in Southern Ocean are very harsh, and there is very low temperature. And the next page, I have mentioned the polar form and Antarctic circumpolar current that restrict the animals to migrate to other place. Yeah.
In the page 9. Why does the research choose those two locations?
Because these two places find the most hydrothermal vent and many activities in these two places. But in Southern Ocean, there is quite empty in other places. Yeah.
Okay, thank you.
All right. Regarding, so first of all, about your stage performance, you are very, you look very confident and you talk smoothly with a good speed. That's perfect. But at the beginning and actually also at the later point, you were pointing like this. You know, when you do this, we don't know what you are pointing at. Always use pointer like this. Use mouse. Maybe I should say that. Use the pointer, okay? And you know your line very well, so you don't need to look at any form or smart tab, etc. But I don't know if you are aware that you are, I don't know, maybe that's staggering. So a little bit like you will say this, and so that means your sentence is broken. So I suggest that next time you try to, please be aware of this issue and then try to speak without repeating two words. Okay? Good. But I know you did your job because you know your line very well. So that's nice. And then the presentation is nicely, the PowerPoint is nicely prepared because he took advantage of the paper and used many nice photos and meet my standard, that means make the photo super large. I will show you where. So at the beginning, he explained the place where the paper is about. So this is nicely prepared. You see the proportion of the map to the text, so you know it's a good proportion. The image should be larger than the text, and in that sense, he didn't add too much text. So that's a comfortable length or number of words to read. And this is also okay. And this one is also okay. So it's good that at the beginning you explain a few the basic knowledge of hydrothermal vents. Perhaps you would like to, because later you were discussing the difference between diffuse and high temperature vent, maybe. So, and you say something like a diffuse vent has lower temperature. Maybe you can look for some additional figures showing, okay, you have black smokers, but you also have diffuse vent. So there are different types of vent in one region. And this is nice. Okay, so biogeography, when I see this, I hope that you will add the map, and then later came the map, so this is okay. Actually, I think this can be shown together here, my feeling, because when you say this, we don't really know what you're talking about. Okay, so it's nice you look for their photos, the instruments. And now comes the result. And it's nice that you show this, but you actually didn't show the detailed map because you were saying like stair-like structure or crater, right? But here you can't see this. So if I were you, I would use sequential slide when you talk about their topography in detail. I will replace this map with a detail map if you really want to say their topographic difference. And this is self-made, right? So I appreciate that because in the paper it was a table. So this is nice, but I hope that you can highlight seawater with a different color or bold text, because seawater is usually our reference. So you want to be able to find seawater easily. Like I don't see seawater here. Okay. And the same here. You should always have seawater looking differently from others, so that we can easily find it. And maybe I will also use different. I will use bold type for these three and seawater. Then it's easier to find them. And this is good. Now talking about the composition, biological composition, he used this large map. I don't know if it's proteobacteria, but it's good that you find their number. You print the number, and here this is the specific species found in this hydrothermal vent. But then maybe you can recall one of their question. I don't remember the question anymore, but I think in a later, in your slide 19, they say no typical vent fauna. But you didn't show the photo, so we don't know what you mean by typical. So my suggestion is when you want to show some unique creature only found in this hydrothermal vent, you can try to look for some typical animal for the, I think it's a shrimp or crab, I don't know, crabs. You can find the crab, for example, in Okinawa Trough for comparison, because this one look indeed very special. Compared to what I know, that look really special. And this is very astounding. So this is nicely presented. You only need to show a large photo, that's it. And then here, I don't know if there's spatial feature here, but I think this one is special, right? Because it's not the typical mollusk we found in other places. So maybe you can find the mollusks we usually find in other hydrothermal vents for comparison. Then we know, oh yes, they do look special. Okay? Good. So these, I don't know if they are special or not, but maybe you can distinguish, especially for those you mentioned here. Find some photo for comparison. And I'm glad to see that here you mention low dispersal potential, and then you look for this additional image to support which shows the fronts. You see there are many fronts here to show the front clearly, so we know there's a barrier around the Antarctica. That may be the reason for the low dispersion potential. So I think the discussion part is nice and the conclusion is specific enough. So it's a very good talk. Thank you, Boris.